In this lesson, we will use our knowledge of differentiation to solve the following problem. The tangents at x equals 1 over 4 to y equals the square root of x and y equals 1 over the square root of x meet at the point P. Find the coordinates of P. To break down this problem into parts, we will have to follow the following steps. First, we find the equations of the two tangents. One is to the curve y equals the square root of x, and the other y equals 1 over the square root of x. Then, we will find the point P at which the two tangents intersect. Let's start with the first one, y equals the square root of x. And we will build the function f of x, which is equal to the square root of x, bearing in mind the fact that f of x is always equal to the y. The gradient of the tangent is the derivative in the point x equals 1 over 4. So what we need now is the derivative. For this, we will remember our formula for differentiating x to the power of n, which is n times x to the power of n minus 1. So the derivative of x to the power of n is this. And the reason for which we are using this formula is because we know it also applies to x to the power of r, which is also rx to the power of r minus 1, as discussed in the previous lesson. We can then rewrite our function f of x equals the square root of x using fractional indices. F of x is equal to x to the power of the square root is the power 1 over 2. So then, when we are differentiating, when we want to obtain the derivative f dash of x, this will be equal to, using our formula, 1 over 2 times x to the power of 1 over 2 minus 1. This is then equal to 1 over 2 times x to the power of minus 1 over 2. Now x to the power of minus 1 over 2 is 1 over x to the power of 1 over 2, which is 1 over the square root of x. So then we know that this is 1 over the square root of x times 1 over 2 will be 1 over 2 times the square root of x. Our purpose is to obtain the equation for the tangent to the graph in the point where x equals 1 over 4. So we will start with the gradient. F dash of 1 over 4, the point in which we want the tangent, will be 1 over 2 times the square root of 1 over 4. The square root of 1 over 4 is 1 over 2. 1 over 2 times 2 gives us 1, and 1 over 1 is equal to 1. So now we know the gradient for the tangent. So we need the equation for the tangent to the graph. The formula for this is y minus y0 is equal to m times x minus x0. But we also need to know our terms. Y minus y0 will be f of x0. M is the derivative where x equals x0 times x minus x0. Our x0 is 1 over 4. So then we can apply the formula. It's y minus f of 1 over 4, which is equal to f dashed of x0, which we got, it's f dashed of 1 over 4, which is 1, times x minus x0. We won't be writing 1 times x minus x0, we will be writing x minus, and x0 is 1 over 4. What we need then now is f of 1 over 4. And we can do this simply. F of x we know is the square root of x, so f of 1 over 4 will be the square root of 1 over 4, which is equal to 1 over 2. We replace this in the formula. Y minus 1 over 2 is equal to x minus 1 over 4. Then we get y will be equal to x minus 1 over 2 minus 1 over 4 plus 1 over 2, which is x plus 1 over 4. This will be then the equation of the first tangent. And we can write this down. So the first tangent is y equals x plus 1 over 4. And we can start working on our second tangent. The equation for the second curve is y equals 1 over the square root of x. And we will also construct a function for this, g of x, which is equal to 1 over the square root of x. And we can also rewrite this using fractional indices. The square root of x was x to the power of 1 over 2. 1 over the square root of x will be x to the power of minus 1 over 2. And now it's time to find the tangent. For this, we need the derivative, g dashed of x, which is the derivative of x to the power of minus 1 over 2. So we use the same formula. It will be minus 1 over 2 times x to the power of minus 1 over 2 minus 1. This is then equal to minus 1 over 2 times x to the power of minus 3 over 2. And we can take this separately and work with it. X to the power of minus 3 over 2 is 1 over x to the power of 3 over 2, which is equal to 1 over the square root of x cubed. 1 over the square root of x cubed multiplied by 1 over 2 will then give us minus 1 over 2 times the square root of x cubed. We now have our derivative, so we want the tangent in the point where x equals 1 over 4. So we'll find the gradient, g dashed of 1 over 4, which is equal to minus 1 over 2 times the square root of 1 over 4 cubed. This is equal to minus 1 over 2 times 1 over 2 cubed, which is then equal to minus 1 over 2. It's 2 times 1 over 8. So it's minus 1 over 1 over 4, which is equal to minus 4. Same as before, the formula for the tangent to the graph, for the equation of the tangent to the graph, will be y minus g of x0, which is equal to g dashed of x0 times x minus x0, where x0 is equal to 1 over 4. So then we can replace this and get y minus, we need g of x0, so we need g of 1 over 4, which is 1 over the square root of 1 over 4. The square root of 1 over 4 is 1 over 2, so 1 over 1 over 2, that gives us 2. We get then y minus 2 is equal to g dashed of x0 is g dashed of 1 over 4, which is minus 4 times x minus 1 over 4. We then get that y minus 2 will be equal to, expand the brackets, minus 4x plus 1. Minus 2 goes to the other side, so then the equation for the tangent will be y equals minus 4x plus 3. This is the equation of the tangent to the second curve. Now that we have the two, finding the point of intersection means finding the point of intersection of any two straight line graphs. We have their equations here, y equals x plus 1 over 4 and y equals minus 4x plus 3. So what we are doing is we're saying y equals y, which is x plus 1 over 4 is equal to minus 4x plus 3. and we want to get the value of x. This in turn leads to minus 4x we take to the left, so it's x plus 4x, which is 5x, is equal to 3 minus 1 over 4. So then 5x will be equal to, we can use our calculators for this, 2.75, and then we get that x is equal to 2.75 divided by 5, which is equal to 0.55. We have the x coordinate of the point of intersection, so in order to find the y, we can replace the value of x in either of these two equations. We'll always choose the simpler one. So then y is equal to, our x is now 0.55 plus 1 over 4, which is 0.25. So this is equal to 0.8. This means that the coordinates of our point of intersection P are 0.55 and 0.8. So the coordinates of P, 0.55 and 0.8. How did we get this? We got this by breaking down the problem into actually two separate problems. The first one was finding the equations of tangents to the graph, and the second part was, now that we have two straight line graphs, find the point of intersection of these two straight line graphs. Also, what you can do to check your results is using the Desmos graphic plotter. Plot your graphs. So these are my two curves, the red one and the blue one, and the two tangents, the purple tangent to the red curve and the green tangent to the blue curve, and we can check their point of intersection of the two tangents, which will be P of coordinates 0.55 and 0.8. This concludes then our worked example. See you at the next lesson.